Good morning children. Welcome to the LUCID study. Today we are here to discuss the model paper 3 of chemistry senior inter AP. The next question is, what is meant by positive deviations from Raoult's law and how is the sign of delta H mix related to the positive deviation from Raoult's law? So this is a question from the solution topic. When a solution does not obey Raoult's law over an entire range of concentration, that is said to be the non-ideal solution. Then the vapor pressure of such a solution is either higher or lower than predicted from the Raoult's law. When the vapor pressure of the solution is higher than predicted from the Raoult's law, then it is said to be the positive deviation. So we are talking about the positive deviation from the Raoult's law. And the delta H on mixing, it shows a positive sign. It shows a positive sign for the positive deviation. And we have a graph for showing the positive deviation from the Raoult's law. This is a graph when it is obeying the Raoult's law. This is P1, P2, and this is the vapor pressure of the solution. On the x-axis, it is a mole fraction, and on the y-axis, it is a vapor pressure. To show the positive deviation from the Raoult's law, just observe the graph here. So it is showing a positive deviation. This is P1, P2, and this is the vapor pressure of the solution. In the case of the positive deviations from the Raoult's law, AB interactions are weaker than the interactions between the AA and the BB, where A is a solute and B is a solvent. The example is mixture of ethanol and acetone. So this is about the positive deviation from the Raoult's law. The next question is, what is molecularity of a reaction and how it is different from the order of a reaction? Name one bimolecular and one trimolecular gaseous reaction. So this is one of the important question I can say. Define molecularity, then show how it is different from the order of the reaction and give the example for bimolecular reaction and the trimolecular reaction. The molecularity of a reaction. The number of reacting species taking part in the elementary reaction which must collide simultaneously in order to bring about the chemical reaction is called as molecularity of the reaction. So the number of reacting species taking part in the elementary step. Elementary step is a simple step. They collide simultaneously in order to bring about the chemical reaction. Order of the reaction. In the rate equation, that is K is equal to concentration of A to the power X and concentration of B to the power Y. The sum of the powers of the concentration terms of the reactants in the rate law expression is called as the order of the reaction. So these are the powers. So the sum of the powers X plus Y is called as the order of the reaction. Order of the reaction is a experimental value, whereas the molecularity of the reaction is a theoretical value. And order of the reaction, it can be 0, an integer, and even a fraction. Order can be a 0, an integer, and can be a fraction. Whereas the molecularity of the reaction cannot be a 0 and a non-integer. It is always an integer. Molecularity cannot be a 0 and not a non-integer, and cannot be a non-integer. The molecularity of the reaction, it is applicable only for the elementary reactions, whereas the order of the reaction, it is applicable to both elementary reactions as well as the complex reaction. So I said to you, molecularity is applicable only to the elementary reactions, whereas the order of the reaction, it is applicable both to elementary as well as complex reactions. The next is, name one bimolecular and one trimolecular reaction. Bimolecular reaction. 2HI, that is 2 moles of HI, hydrogen iodide, they dissociate to form H2 plus I2. So this is a bimolecular reaction. 2 moles of HI, they are dissociated into H2 plus I2. Next is trimolecular reaction. 2NO plus O2 gives rise to 2NO2. So here 2 plus 1, 3 moles are being involved here. Simultaneous collision will be taking place between 2 moles of NO plus 1 mole of oxygen. Hence it's a trimolecular reaction.